Hi, fourth graders. How are you? This is the last math package you will ever have with me. It's a little sad, isn't it? Okay, maybe you're happy inside. Guess what? I got sick over Memorial Day weekend. I lost my voice. So you have to bear with me as I do this video. I might need to take some water breaks. Today, fourth graders, you get to hang out with Mortimer Mouse. Pretty exciting. And he's going to tell us a joke. How do you keep warm in a square room? Be thinking about that, fourth graders. Today, Mortimer wants us to be able to measure angles using a protractor. Protractor. Say that word again. Protractor. It's kind of a silly word. Kind of a weird word. Kind of a complicated word. But it's for a really simple little thing. We have a whole bucket of things like this in our room. Hopefully I've already shown it to you. This particular one says the word something on it. Anyways, this was someone else's protractor before it was in my hands. But we can use this special machine to help us measure angles and how many degrees they are. So we're going to go ahead and write this down. This is a protractor. It is used to measure angles, and angles are measured in degrees. So if you look, we're getting close. If you look at the side of your protractor, you'll see that it starts at 0 here, and then it's going to go up by degrees. So we're going to look at this bottom line. It starts at 0, 10, 20, 30, 40. So depending on how big our angle is, it's going to go up by degrees going like this. You see 180 there on the other side, and that would be just if we started measuring from the other side. So you can see there's a 0 here, and it goes all the way around on the other side. So take a second to look at your protractor, kind of look at how we can measure angles using it. Real fast, let's also make sure we are 100% clear on the different types of angles. There are some angles that make a perfect right. That means they cross each other perpendicularly. And if that is the case, they are right angles, and they are exactly, if you were to look on here, 90 degrees. So see how that line goes up to 90? They are exactly 90 degrees. Now, if you have an angle that's less than 90 degrees, then it's a acute angle. And I remember that because acute makes me think of something small and little. Acute angle, that's going to be less than 90 degrees. And of course, we have one that is a big angle, bigger than 90 degrees, and we call that obtuse. That would be an obtuse angle. Here's something I want you to think about. Yes, there's a sprinkler there. Summer is here. Maybe you've seen some sprinklers in your yard. But this particular sprinkler has a radius. All sprinklers do. Here's where the sprinkler is, and they will spray water out all the way around. And then they might turn around again and go and spray water out all the way around. So think of rays and angles and protractors kind of like you might think about a sprinkler. That it's spurting water out, and because the sprinkler head stays in the same spot on that little dot, it just goes all the way around and then it goes back. But it can't go any further than our protractor. Now, Here's another way of thinking about this. Whoa, yes, it's true. This is a circular protractor. So we can think about angles stopping at 180 degrees, like the one we had here, right? But we can also think about angles continuing to go all the way around until they get to 360. So an angle or a sprinkler could go, and if it didn't stop there, it could keep going, spurting its water all the way back to where it started. Sometimes we say, oh man, he landed a 360. That might mean like a skateboarder or a snowboarder has just turned around completely. Has like just flipped around completely and is back to exactly where they were to begin with. That would be a 360 degree flip. Cool, huh? Okay. Something to think about. Try the next page in your packet on your own. See what you can do. If you need help, raise your hand and let me know.